Welcome back, everybody. This should be the very last video you guys will be watching of me before I come back. So, what we're going to cover today is trigonometry. And once we're done with this, when I get back, hopefully we will test. If you aren't already ahead of the game and you end up testing right before I get back. But the plan is we will test on both trigonometry and similarity the second day I get back. The first day we'll do a little bit of review, then we'll have a test, and then we're going to move on to our final two units, which are circles and three-dimensional solids. So we're going to start today by talking about trigonometry and what exactly it does. And to do that, I've got a couple triangles on the board which you guys should be familiar with. You've got a 3, 4, 5 triangle. It's a right triangle. It's a Pythagorean triple. And based on what we know about similarity, we can use the same ratios to make more triangles that are of varying sizes. I want you to imagine, though, what if I didn't give you the other triangles to try to figure out exactly how big the sides were? Could we do it? Let's say, for instance, we didn't know what 15 was and I wanted to figure it out. Without those other triangles, we can't use similarity. But we can still solve it. This is still a right triangle. We could still use the Pythagorean theorem. And by doing so, we'd be able to find out that the third side is 15. Let's say, though, we had even less information. Let's say I only gave you the 12. And I asked you to find any missing values in this triangle, any missing sides. Well, we can't do it as currently situated based on what we know, but what we're going to talk about today is a way that if we're just given a side or we're just given an angle, how we can find any missing sides or angles in a right triangle by using what's known as trigonometry. Now, what trigonometry is a way of converting degrees of measure as far as angles go into decimals. And the reason that's useful is because of what we've talked about this whole week about similarity, which is the idea that because we know the side-angle relationship, because we know that there is one, if you're given a side, you're going to be able to know something about the angle across from it. And in a right triangle, if you're given the angle across from it, let's say, what we're also going to be able to know is what the other angles are, because you know this is 90 degrees. So if I give you one angle that's not 90 degrees, that means you have two angles, which means really you have all three. If I don't give you an angle, if I give you a side, what we're going to know, because it's a right triangle, is that there's a certain ratio that must be there with the other sides for this to work. Now, because we know what those ratios are, what we've done is compiled those ratios, and we've been able to figure out however big this angle might be, or that angle might be, it's going to dictate the relationship between any two given sides in this triangle. So if I tell you exactly how big this angle is, I'm going to know exactly what the ratio is between these two sides, or what the ratio is between these two sides, or between these two sides. And I'm going to be able to use that information to take less information than we're used to figure out anything else about that triangle that we want. So that's the idea behind trigonometry. We're going to convert a degree to a decimal, or a decimal to a degree, to find either a missing side or a missing angle. Now, in order to do that, we need to know exactly how trigonometry is going to work. It's based off of this idea. Whichever angle you're given, or whichever angle you're trying to find, let's say it's the red angle here, I'm going to be able to recognize the relationship of those three sides to one another in relation to that angle. So we always know where the hypotenuse is. It's always across from the 90-degree angle. But what we're going to be able to find out now is the other two sides of this right triangle. I'm going to be able to determine which one is what we're going to refer to as the opposite side, and which one's going to be the adjacent side. So the opposite side is going to be directly across from the angle. The adjacent side is going to help form the angle. It's going to be right next to it. Now, that works for the red angle here. For the green angle that I've given you, it's going to work the same way, but they're not going to be the same sides as it was for the red angle. So if you look at the green angle, hypotenuse is still the same. The opposite side is going to be across from the green angle, and the adjacent side also is going to be next to the green angle, just like it was with the red angle. So what we're going to do is we're going to label these three sides And based on those three sides, whether they're opposite, adjacent, or hypotenuse to the angle we're dealing with, we're going to be able to set up a ratio. Now we call those three ratios sine, cosine, and tangent. And they refer to any of the pairs of ratios we could get. So sine is going to be the opposite side divided by the hypotenuse. Whatever decimal we're going to get there, we can convert that decimal into a degree in order to find a missing angle. Or we can use the degree that we know and whatever side we were given to find the other side. So that's what sine is. It's the opposite over the hypotenuse. Cosine is going to be the adjacent side over the hypotenuse. And tangent is going to be the opposite side over the adjacent side. Now those are going to be the only three ratios we can find. So as long as you know sine, cosine, and tangent, as long as you're aware of what they are, you can use any of the combinations of sides that you're given or combinations of angles that you're given to figure out whatever information it is you're looking for. So what you've noticed written above, hopefully, above sine, cosine, and tangent here is SOHCAHTOA. Now we use this as a device to remember exactly which sides go with which ratio. So you'll notice here we have sine equals opposite over hypotenuse, that's SOH, right? You're going to notice the same thing with cosine, CAH, and you're going to notice the same thing with tangent, TOA. So there's our CAH and our TOA. So now that you know the idea behind sine, cosine, and tangent and what exactly they are, let's talk about how we can use this information in order to find a missing side or a missing angle. Now the process is pretty similar. We're going to start off the same way, whether we're looking for a missing side or a missing angle. But what we're going to do is change up once we've got our equation solved so that we can solve for whatever's missing, because obviously we're missing something different in both of those situations. So let's start. I'm going to use this example because we've already talked about it. In fact, you already know that it's a 9, 12, 15 right triangle. Okay, it's not a special right triangle, but what we're going to do is similar in that vein, in that we're going to use what we know, some standard measurement, and we're going to apply it to some triangle that we don't know. So here is our 9, 12, 15. I'm going to redraw it. 9, we have 12, we have 15. Here's our right triangle. And what we're going to do is we're going to try to find a missing angle. Now, it doesn't matter which one we're looking for. Let's say we're looking for this angle over here. Okay, I'm going to label it. You could label it X if you want. I'm going to label it theta. In fact, you know what? I'll label it X just because I know that's going to be a little easier for you guys because we haven't really talked about what theta is. But if you're wondering what that symbol is, it's theta. It's what we usually use to represent a missing angle, so we don't confuse it with anything else. But I'll plug in X there for now. What we're going to do is we're going to try to find out how big is this angle. So this is a process we're going to follow. The first thing we want to do is we want to figure out, of the three sides we were given, which one's opposite, which one's adjacent, and which one's hypotenuse. Now I've given you three sides here. Let's pretend we just have two. So let's say we don't have the 9. Let's say we have the 15 and we have the 12. What we're going to do is we're going to label all three of these sides. It doesn't matter if we know how big the side is or we don't. We want to label all three. So based on where this angle is, we know, first off, that this is going to be the hypotenuse. So I'm just going to label that H. I know that directly across from this angle is the opposite side, so this is going to be O. And I know that adjacent A is going to be this side over here. And I know that because it's helping to form with the hypotenuse this angle. And of course the opposite side is directly across. So we've labeled the three sides. That's the first thing we want to do. Once we've labeled the three sides, what we want to do is determine which two sides we want to use. If we were given all three sides, we get to pick. If you're not given all three sides, you want to look at what you were given. So in this case, we were given 12, we were given 15. 12 is opposite, 15 is hypotenuse. So we're going to use whichever ratio, sine, cosine, or tangent, uses opposite and hypotenuse. So that's what we're going to look for next. So we take a look. Sine is opposite and hypotenuse, so we're going to use sine in this case. If not, we check cosine and see if it was. We check tangent and see it was. In this case, it's going to be sine. So what we're going to do is we're going to write sine of whatever the angle is, which in this case is x. So I'm going to write sine of x, and that's going to equal whatever it is the ratio was that I got before. So we know that our opposite side is 12. I'm going to put in 12 for the opposite side in the numerator there. And in the denominator, I'm going to have my hypotenuse, which is 15. So I know that the sine of x is going to be 12 over 15. So it doesn't matter which one of the triangles I used before, that ratio will hold true. So if you remember the other triangles we had a 3, 4, 5, we had a 6, 8, 10, and we had a 9, 12, 15. What you'd notice is the values we had here. If we had 4 and 5, it would be 4/5, which is the same thing as 12 over 15, or it would be 8/10, it would be the same thing as 12 over 15. We're going to see that same ratio over and over again for a triangle with the angles that were listed. All right? Now, we don't know the angles, but that's how this works, is that because we know that ratio will be the same every time, we're going to be able to figure out what the angle is the same way every time. So here's our triangle. We've labeled all three sides. We've determined whether we're going to use sine, cosine, or tangent. And then we've set up this equation where we use either sine, cosine, or tangent, whichever one we're using, of whatever angle we have. And then we're going to plug in the two sides that we know. Now, sometimes you're going to be given a side and an angle. Sometimes you're going to be given two sides and you're looking for the angle. But it's going to fit that format every time. So here's our equation. Now what we're going to do is we're looking for a missing angle. So we're just going to follow this list over here. If we're looking for a missing side, we'd get to this point and then we'd follow that list over there. So missing angle. So the first thing we're going to do is we're going to convert this fraction into a decimal. So the way we do that, you just divide the numerator by the denominator. 12 divided by 15 is going to get us 0.8. So we know that sine of x is going to equal 0.8. The next thing we're going to do is we're going to use the inverse of sine, the inverse of cosine, or the inverse of tangent to convert a decimal to a degree. So I'm going to show you how to do that on a couple of calculators. There's really three, I think, where you might be using, or you most likely will be using. So the first one I'm going to show you is on here. So if you have a calculator that looks like this, all right, TI-30, what you would do, and you'll notice it's going to be similar no matter which scientific calculator you have that looks like this, or which graphing calculator you have. If you have the single bar of text at the top, you're going to use the method that we're going to talk about here. So what you're going to do is you're going to type in 0.8, and then what you're going to do is you're going to hit second, and you're going to hit sine. And what that's going to do is take the inverse of sine, and we'll talk about exactly what that means in a second. And you'll notice on here we have 53.13, and it keeps going for a while. You can round to the nearest tenth of a degree. So if you did that, we would get 53.1. So what this is telling us is that this angle over here is 53.1 degrees. Okay, and the whole point of this is to find out what decimal we're going to get that represents the ratio of the two sides that we know, to work backwards to find out what degree is equivalent to that decimal. So we're converting our decimal to a degree, and that's what we're doing when we take the inverse of sine. So we wouldn't have sine x anymore, it would just be x. X would be 53.1 degrees. The reason we take the inverse of sine is because we're trying to undo this, right? Sine of x. What that's doing is converting a degree to a decimal. We're going back. We're going from decimal to a degree, so we're getting rid of that. We're taking the inverse of sine. When you do it to both sides, whenever you take an inverse of anything, it'll cancel out, and so you would do the same thing here. We're taking the inverse of sine. Now let's say you don't have that calculator. Here's another one you might have, also a TI-30, but a different kind. You'll notice on this one, sorry, a little bit of glare. Let's see if we can get that right. Okay, you'll notice on this one, there's two lines of text. So there's a line of text where you're going to be typing, and then it gives you an answer right below. So what we're going to do is we're going to do the same thing, but we're going to do it a little reversed. We're going to hit second sine, and you'll notice it'll come up inverse of sine. So you see sine to the negative first power, and then it'll leave you parentheses, and you just want to type the decimal. So we do 0.8, and we would hit enter, and there it is again. We get 53.13 and so on. We round it, we get 53.1. The final type of calculator that you may have is the graphing calculator. So here's an example of a TI-84. Again, same idea. Same idea as the last one. You're just going to hit second and then sine. And you'll notice again, inverse of sine. Now what you're going to do is you're going to type in 0.8. You're going to hit enter. And you're going to see you're going to get the same degree no matter which calculator you use. So if you get a little stuck using your calculator, those are going to be the methods you could use. It's most likely going to be one of those calculators. If you have one that's maybe a different make or model, easiest way to figure it out is just type in whatever calculator you have, the make, the model. Usually it's written on the calculator. I would do a quick Google search and then type in whatever it is you're trying to do. And typically somebody else has had that problem before you. You're going to be able to just read about what they did to figure it out. So that's probably the easiest way to do it. To figure out exactly how to use it. Obviously you can refer to a user's manual as well, but I feel like a lot of the times it's a little easier to understand if you just read it online because somebody's already typed it up in a way that makes sense. So that's what we're going to do to find a missing degree. We'll go back, we'll practice one of these again. I want to show you a missing side first because it is a little different than a missing angle. And then maybe we'll try one more of each just so you can see how quick and easy it can be. So why don't we use the same exact example, okay? You know what? It'll be a little different because the degree is going to be off. So I'm going to erase this, and I'm going to use a triangle that we do know. I'm going to use a special right triangle because you should be familiar with how big each of those sides should be. So here's a special right triangle. So I'm going to give you 60 degrees over here. And let's say I know how big this side is. This is 5. So we should be able to recognize, because it's a special right triangle, we'd have x radical 3, 2x. But let's pretend we didn't know that and we wanted to solve this another way. I'm going to show you this example, so it should be easy. We should expect this to be 10 when we're done, because of what we know about special right triangles. But it doesn't have to be a 30, 60, 90 for us to be able to solve by trigonometry. We could have whatever degree we want in here, and we'll try one of those after. But I want to at least show you how it works with a triangle you already know. So here it is. We've got this triangle. We have a side, we have an angle, and let's say we're looking for this side over here. We're going to set it up the same way as before. We want to label which side is opposite, adjacent, or hypotenuse relative to this angle. So we already know this is going to be our hypotenuse. It's across from the 90-degree angle. It's the other two angles we're more concerned with. This is opposite. This is adjacent because it's next to. So there's our three sides. We've labeled our three sides. Now what we want to do is determine the two sides we need to use. So you notice you're not given two sides that we know of, but we are given one side, the 5, and another side that we're looking for. So what we're going to do is we're going to use the two sides we're looking for, or the two sides that we have something for. So we have the 5, we know what it is, and this side we want to know. So those are going to be the two sides we use. So we're going to be dealing with adjacent and hypotenuse. So the next thing we want to do is determine the two sides we're using, adjacent and hypotenuse, then use SOHCAHTOA to be able to figure out if we're going to use sine, cosine, or tangent. So here's sine, we have opposite hypotenuse, that's not it. Here's cosine, adjacent and hypotenuse. That's what we're looking for, so we're going to use cosine. So what we're going to do is we're going to write cosine of whatever it is the degree is, which in this case is 60 degrees. And that's going to equal our ratio that we can set up. So it's going to be adjacent over hypotenuse, so we're going to get 5 over x. So that's our setup, whether we're looking for a missing side or a missing angle. The next thing we're going to do, now that we've set up the following equation, is we're going to follow the steps to find a missing side. What we're going to do is we're going to use the sine, cosine, or tangent, depending on which one we use, which in our case right now is cosine, to convert the degree to a decimal. So all you have to do on your calculators, and I'll show you this one first, is you're going to type in cosine of 60 degrees. So for this one, you're going to type in 60 first, and then you're going to hit cosine. You'll notice you get 0.5. You can do the same thing with either of the other types of calculators. I'll show you the graphing calculator. Again, you're going to type in cosine of 60, and you'll hit enter, and you'll get 0.5. If, for some reason, you're doing this and everybody else is getting different values than you, I would hit the button that says mode, and you'll notice here that I have degree darkened out because I'm in degree mode. The default is set to radian mode, so if you haven't played around with it, it's in radian mode. You're not going to use that here. When we get further with math, when you're in pre-calc and calculus, you may use it there, but we're going to stick to degree mode for now. So we're going to go to degree mode if it's not set that way. So if it looks like this to start, just slide over, hit enter on degree, and then now it's set to degree mode, and now you can hit seconded mode to quit, to back out. So what we would do is we would hit cosine and then 60, and then you'd see you get 0.5 as your answer. So that's what we're looking to do with this calculator. So if you get a little stuck, just double check what mode you're in. And really that goes for any calculator, but that's the easiest one or the most likely one where that's going to be an issue. So anyway, back to our problem. We have cosine of 60 degrees. We just found out that it equals 0.5, so I'm going to write that in. Cosine of 60 degrees equals 0.5, and that's going to equal 5 over x. So our final step is we're going to put the decimal that we just got over 1, and then we're just going to cross multiply. So we're going to do 0.5 times x, and we're going to do 5 times 1. So we're going to get 0.5x equals 5 times 1, which is 5. If you divide both sides by 0.5, you're going to find out these cancel out, so we're left with x. 5 divided by 0.5 is 10, because it's a half, right? So how many halves go into 5? There's 10 of them. So that's the process. Label the sides, find out which two sides you want to use, set up the equation, and then following here, use sine, cosine, or tangent to convert the degree to a decimal, and then you want to put the decimal over 1 and cross multiply. So that's what we do with the missing side. All right, we'll work through 2 more problems. We're going to work through one where it's a missing angle, one where it's a missing side, just so you can see how it looks now that we've been through the process. But that's really the whole idea with trig. This is really useful. This is probably, of all the things we've learned in this class, outside of maybe area, going to be the thing you use most often. If you need to measure something and you can't easily measure it by grabbing a tape measure or anything like that, using trigonometry will help you be able to solve it. So, and if you think about it, we've got a diagonal line here, but we're using vertical and horizontal components, just like we were when we were finding distance or using the Pythagorean theorem or anything else. And that those vertical and horizontal components are usually the easiest things to measure. So that's why we tend to use it this way. You can indirectly measure for any missing value that's maybe difficult to do just with a typical tape measure. So let's try 2 more examples. The nice thing about trigonometry is there's no special cases here. We just sort of follow the same rules every time and we'll be all set. So what we're going to do, I'm just going to make up a problem, and it doesn't really matter how it looks or what we're doing. It's a little different here because it's on tape. Normally I just have you guys blurt out random numbers. But let's say, I don't know, let's say we made this 10. And let's say I made this, I don't know, 14. All right, so we have 14 and 10, and let's say we're trying to solve for this missing angle over here. All right, so we want to know exactly how big that angle is going to be. So we're going to follow our steps, which I should probably move out of the way of. So we want to label which side is opposite, adjacent, and hypotenuse first. So take a look, see if you can do it yourself for a second. I'll give you guys a couple seconds to figure it out. Hopefully you have an idea at this point which side is which. The first thing you should look to do is the hypotenuse. So if you're looking, we've got our right angle. We look across from it. There's our hypotenuse. Now we only have 2 sides left to label. So we look at our angle and we ask which one's opposite. This one over here. Which one's adjacent or next to. this one over here. So now what we're going to do, we're going to determine which two sides we're using, and does that mean sine, cosine, or tangent? So we take a look, try to figure out which two sides you're using. Try to figure out whether that's sine, cosine, or tangent. Hopefully you have an idea at this point. So we take a look. We're going to use opposite and adjacent. The reason for that is we were given those two sides. All right? We don't have anything for hypotenuse, so it's not going to help us. It's in our best interest to use these two. So that's what we're going to do. We've got opposite and adjacent. You'll notice it's for tangent, so it means we're going to use tangent. Opposite hypotenuse, not going to use it. Adjacent hypotenuse, not going to use it. Opposite adjacent, that's the one we want. So we're going to use tangent of x equals, and then opposite over adjacent. So tangent of x equals opposite, which is 10, over adjacent, which is 14. So there's our equation. Now what we want to do, we're solving for a missing angle. So we're going to follow along on this path. We're going to convert the fraction on the right side to a decimal. So we're going to do 10 divided by 14. When we do that, we're going to end up getting 0.7142857143. It's going to keep going. What I want you to do, though, is I want you to use at least 4 decimal places, or at least 4 values after the decimal place if you're going to round. Right? And when I get back, I'll show you what to do if you don't have a calculator, how you can calculate this. Before calculators, there were tables made with degrees, and you would have to use an approximation to figure out exactly where you were. We don't have to do that anymore because we have calculators, but that's where this is coming from, and you'll see when you look at the decimals that are listed there, you're using at least 4 places after the decimal place. And the reason was you wanted to be as precise as possible, but at the same time they didn't want to list huge decimal number approximations because you didn't need all those decimal places typically. So 4 decimal places was kind of the happy medium they decided on. This is how many would get us a fairly accurate answer while at the same time not driving everybody insane by using massively large decimals. So 10 over 14, we have 0.71428, so I'm going to round it to 43, 0.7143. We're going to have the tangent of x. Now, if you wanted a more precise answer, you could just use that decimal, but for our sake, because we're not all working with the same materials necessarily, I'm going to just have you round for now. On the test, I'll give you the benefit of the doubt. If you do it one way or the other, I'll have both answers, I'll check, and hopefully you've shown your work to show that you're doing it the right way. Anyway, back to this. We have the tangent of x equals this decimal. We've converted the fraction. We now want to use the inverse of sine, cosine, or tangent to convert the decimal to a degree to figure out how big x would be. So when we take the inverse of tangent, because we're using tangent here, you just want to take, in this case, second tangent, and then you type in the decimal. Or if you're using this calculator, you want to type in the decimal first and then do second tangent. 0.7143. And what we'll find is that we're 35.5 degrees. You might be off by a couple tenths if you use the more precise answer. If anything, I'm the one who's a little off if that's the case. But either way, we're going to get an answer that's about there. If you're within a degree, I'll be happy. So we would have 35.5 degrees if that was the case. So again, we had tangent of x equals this decimal. We take the inverse of tangent in order to get rid of the decimal and turn it into a degree. Hopefully that's what you guys received as your answer. And all we did was we just followed these steps. Final problem we're going to do, we'll do one more. Only this time we'll solve for a missing side, which we did already, but this time we'll do it with a little bit of a break so you guys can figure out what to do. So, let's say, and here's an example of how we might see this problem. Let's say we had ourselves a flagpole. We wanted to figure out how tall it was, but we weren't sure. What we could do is we could measure off a certain distance, and we could figure out that that's going to be a right triangle because this is 90 degrees. And then what we could do is just measure our angle, and there are certain ways you can do that. You'd use what's known as a sextant. It would measure the angle from the horizon or from whatever level ground you're standing at, find the angle you're looking for, and then from there we'd be able to figure it out. So what we're going to do is we're just going to make up an angle. Let's say this is 40 degrees. So we have a 40-degree angle, and let's say I stepped 30 feet away. All right. So here's the problem. We have a flagpole. We don't know how tall it is. We want to know how tall it is. So what we do is we marched off 30 feet. We took out our sextant. We measured the angle of elevation. It's 40 degrees. So what we're going to do now is set up this problem. This problem is set up. You don't need the flag in there anymore. You can visualize it as if it's just a triangle, and it's a right triangle at that. So there's our problem. And now all we have to do is solve for what we're looking for, which in this case is x. So there's our problem set up. So that was a typical word problem. We just want to take the information we're given. We want to write it out. We want to organize the information. And then laying it out via a picture is typically helpful. But just setting it up in a way that you're going to understand it and you're going to be able to pull out the information you need really is paramount. So however you do that, typically most people do it by picture, but if you use another way, that's fine too, as long as it works for you. Now that we've got it set up though, what we want to do is figure out exactly what we're going to need. So think about what the first thing is that we need to do. If you're literate, that shouldn't be a problem. So take a second, figure out what you're going to try to do. Okay, hopefully that's enough time. Hopefully you were also trying to label which side is which. So across from the 90-degree angle, there's our hypotenuse. Across from the angle we're looking at is going to be opposite. Next to the angle we're looking at is going to be adjacent. There are our three sides. Now that we have our three sides, figure out exactly what you need to do. Okay, hopefully you've looked at this problem. You've figured out exactly what you need to do. In the next step, you're going to look for the two sides that we're going to use. In this case, it's going to be the adjacent side and the opposite side. And we're going to figure out, is that sine, cosine, or tangent? So opposite and adjacent. Opposite and hypotenuse, that's not it. Adjacent and hypotenuse, not it. Opposite and adjacent. We're going to use tangent. So we're going to write this out. Tangent of our degree, which is 40 degrees, is going to equal our ratio, opposite over adjacent. So here's our opposite, x, over our adjacent, which is 30. Hopefully that makes sense. We're just following along the path. It's really as simple as understanding what the process is and being able to execute. So we have the tangent of 40 degrees equals x over 30. The next thing we're going to do is we're solving for a missing side. So we're going to follow along that path here. Step 4, step 5. So the next thing we're going to do is use sine, cosine, or tangent to convert the degree to a decimal. So there's our degree. We know we're using tangent. Try to do that now. I'm going to walk off screen and do it myself. I'll put up the answer in a minute. All right, hopefully that's enough time, and hopefully you received this as your answer, 0.83909963112. Again, we'll just round, so we'll do 0.8391. That'll be fine for us. So we're going to take the tangent of 40 degrees, and we know that that's 0.8391, and that's going to equal x over 30. Our final step, put the decimal over 1, cross multiply. 1 times x is x, that's nice and easy. 0.8391 times 30. It's going to be 25.17. If you were rounding to the nearest tenth, it would be 25.2. And if we were using feet before, it would be 25.2 feet. And that's it. That's all you have to do. So I'm going to clear out, move out of the way, leave this on the screen. If you haven't copied down the process yet, I would strongly suggest doing so. And the next time you hear my voice, I'll be standing in front of you.